Welcome to today's webinar, End-to-End Dosimetry Audit for SRS SBRT, optional or mandatory at the beginning of the journey. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You have joined the presentation listening through your computer's speaker system by default. To adjust your audio, such as selecting different speakers, click the settings wheel at the top right of the GoToWebinar window. You may also enable closed captioning for this presentation by clicking the CC icon located towards the bottom right of the window. Today's webinar is presented by Florin Kostaki. Florin is a medical physicist expert in radiotherapy across multiple clinics. Sponsored by RTsafe, this webinar focuses on the implementation of end-to-end dosimetry audits for SRS SBRT treatments using the RTsafe independent audit system on a Varian Halcyon machine. Florin welcomes your questions. You can submit your questions at any time during the presentation by typing them into the questions panel. To access this panel, click the questions icon at the top right. Florin will answer as many questions as possible during the Q&A session, and any remaining questions will be answered by email once the webinar is over. It's now my pleasure to introduce your speaker, Florin.
Thank you, Chloe, for your introduction. So, Chloe said, I am a medical physicist expert working in radiotherapy. I have like 20 years experience. And today I am in front of you trying to share my experience with RTsafe succeSRS SBRT implementation for this Varian Halcyon machine. First of all, I want to share my disclaimers. So I don't have any conflict of interest to report, and I will go further to be much faster, to have time to answer at the end to your question. So I am coming from a clinic, a radiotherapy clinic department located in the city of Craiova, Romania. It is in south of Romania. It is an oncology platform built on approximately 2,000 square meters. It's a dedicated clinic for oncology, but 6 years ago, we started also a project for radiotherapy. And this is something that makes us to have a new team, to have a new RTT physicist and so on. I was the only one with experience. So on this journey, we have a lot of things to improve and a lot of experience to gain. Future project for this nice investigation, it is that we need to go for nuclear medicine and also for oncological surgery. So to become a full platform to provide to the patient full treatment for the oncological patient, full treatments. So this is our let's say general presentation of the clinic. In our department, radiotherapy department, it's a small department. Like I said, we belong to a very high oncological clinic. In this small department, we have 2 Halcyon. We start with 2 Halcyon, version 3.1, with Eclipse system planning. And also we have SGRT system. Also for the patient-specific way, we are using matrix resolution from EBA. And now these days, when we start SRS SBRT, we are using MyQSRS system. Or for the secondary check for TPS, we have Mobius 3D, and also we are using portal dosimetry from the Varian. Like staff in the department, there are 6 radiation oncologists, 4 medical physicists, and 13 radiation therapists. Of course, in the department, being connected also with the university, medicine school, and also physics faculty, we have some residents from radiation oncology, and also some junior medical physicists together with the practical radiation therapist. So we are a young department in my terms of the radiotherapy field. Like I said, we have 2 Varian Linac systems, and I want to share with you just a slide with some basic information about Varian Halcyon Linac. It's a treatment delivery. It's a ring entry based treatment delivery with a photon energy of 6 MeV FFF, and a dose rate of 800 mu per minute with a very nice speed of gantry that provide us CBCT on 4 rotation per minute and VMAT treatments with the 2 rotation per minute maximum gantry speed. In fact, it's looking like a CT, but like a CT design, but it works like a LINAC. The nice part and the different part from the previous machine that was provided by Varian, it's the MLC. This time it's we don't have jaws, and it's a dual layer MLC, and because of this dual layer and because of this interdigitation of the MLC, we have the chance to have very low leakage on the MLC. It's below 0.1%. Also, the MLC velocity, it is very high. That's why we have the chance to increase the modulation and to use this let's say opportunity to do very nice plans. Imaging part, it is something very strictly, because the machine, it is 100% IGRT machine. You cannot treat without an IGRT image before starting the treatment. And if we talk about some dosimetric characteristic here, we can see some comparison between Halcyon, succeSRS machine and a TrueBeam with this opportunity of 2 energy, 6 FFF and 6 free flat with flattening filter. So it is not a big difference. The difference, it is in what MLC it is built, and also the difference is coming from the geometry of the machine, and also this can be an advantage because we have high-speed gantry rotation, and also a disadvantage because we don't have the chance to have couch rotation. So pluses and minuses on this machine. We decide to take this machine, and we decide to take 2 of this machine because, like you said, like I present in the previous slide, we have a lot of patients that we treat today. The average in the last 4 years is 130 patients per day. So it's a lot of, it's a high number of the patients, and we have peaks in some days like 150, 155 patients treated per day. This is the reason that we jump to this machine. In these days, this year, we understand that we need to provide also SRS SBRT treatment for the patient. That's why before of this, we need to talk something also about the precision in radiotherapy, because it's very important. It's very important because even small errors, starting from the CT acquisition, then jumping to contouring, planning, dosimetry, treatment delivery, or patient position, you know, can lead to negative consequences to the plan, to the patient in the end. We know this picture, all of us, that just plus minus 5% dose difference from the prescription one. If we look to this graphic of the dose versus person response of the treatment in the tumor control and normal tissue damages, the results are not linear. So plus minus 5% can lead to difference in the 10, 20, or maybe 30% changes. If we talk about tumor control, is 10, 20 tumor control differences, or in NTCP, in normal tissue damages, it is more than this. It is like 20, 30%. So precision in radiotherapy, it's very important. And when we jump to some very high dose prescription, this is become much more important and need much more attention. If we look to the contribution of the uncertainty in the final dose delivered to the patient, we can find many reasons of this uncertainty. They can come from the absorbed dose under reference condition, you know, the output of the machine. It comes from the TPS calculation, different algorithms, different calculation. It comes, and these two can affect all the patients if we don't have something very strong selected or tested. Also, 2% can come from the position of the patient, of the source in the patient, or 3% because of the movement during the or between treatment fraction, and also another 2% we can add from the machine QA. And we don't stop here. We have also other elements that we can identify. And like I said in the previous slide, we want to maintain everything under 5%, and if we sum all of this, it is more than 11%. So it is very important to be as low as possible in all of these elements to have this uncertainty as low as possible. Coming to the clinical workflow for SRS SBRT, it is looking the same. All of us know it is looking the same like a conventional radiotherapy, but like also the task group says, important it is to introduce also other modality for contouring. So we need also to include MRI or PET-CT in this workflow, and of course each workflow in the QA mode need to have other tolerances. We need to use other standards to QA the machine or the task that we are doing. Yeah, how we can do this? We can do this using the barriers. This is very important, and this is something that I like very much when I try to develop a new center of radiotherapy, to identify what are the barriers that I can apply on each of these steps in the end to minimize that uncertainties. So every time we want to stay in this acceptable zone of risk. This is a farmer curve. And this is the effect between severity and probability. So we have two ways of using these barriers by prevention. That is a reactive system, and it's belong to a quality control test. And also we can use also mitigation. That is a proactive element, and it's belong to a quality assurance, to a procedure that we made to identify how to minimize the effect of one let's say mistake. So using mitigation and prevention, in the end, it is translated using a quality system, quality management system, that is mean quality assurance and quality control, we can stay in an acceptable risk. This is something that, like I said, we can implement on each step of our journey, from the patient selection to the treatment that we apply to the patient. Quality assurance principle in for SRS SBRT program, it is much more the same with the conventional radiotherapy, but it is much more stringent. Why? Because, like I said, we deliver high doses per fraction for the patient, and one small mistake, it can be fatal for the patient. So in this way, we have daily QA test, monthly QA test, annual QA test, patient-specific QA test. All of them can be done according with the reference guidelines like AAPM TG 142. That is machine QA, but this time we need to implement the values that are applying for SRS SBRT program, or we can also look to the TG 101 SBRT QA or TG 133 for in case that we have QA for robotic radiosurgery, and also AAPM Astro guideline for SBRT physics. Definition of end-to-end tests. So until now, we talk about what we can do in our clinic with our, let's say, classical devices. And what is this end-to-end test, and how they can help us in, let's say, an SRS SBRT program. End-to-end test, it's a methodology that it's used to test the flow of an application from the start point to the finish point. So it is something that at the end, it tests all the workflow for the treatment. This is the end-to-end test. The purpose is carry out of the end-to-end test in radiation oncology come to identify the system dependencies, to ensure that the intended information is correctly passed between various system components, and also to verify that clinical team members understand their task. So also the training of the team can be verified with this end-to-end test, and also to access overall treatment process accuracy. All aspects of the treatment process should be considered during this end-to-end test, including immobilization, simulation, respiratory related motion management, treatment planning, and treatment delivery using a clinical relevant image guidance method. Each step of end-to-end test should be performed by the staff member who will perform the step in the real clinical life. This is very important. Otherwise, we will not have a real result of the end in the end of this test, because we if it's performed just by only the experienced one, for sure the result will be good. But in the real life, if we involve all the members of the team, we can have exactly an image of our department workflow. Good. Looking to this publication, Medical Physics RSS Medical Physics Practice Guideline 9.A from AAPM regarding SRS SBRT, we will see that for this type of treatment we have some recommendations. Some recommendation for the CR machine or for helical tomotherapy, also for robotic radiosurgery exists, but I stop here because I have a ring machine. It's not a CR, but it's something that is looking for like a helical tomotherapy, the design, but not the functionality. And if we are looking there, the recommendation it is to perform some annually end-to-end test, dosimetric end-to-end test. So I said, and we said, why not to use also and to apply to a ring entry Linux system? I think it is feasible to use the same recommendation. And as we were in the position to start an SRS SBRT program with a machine that, like we saw in the second slice, is not let's say a dedicated machine for SRS that Varian marketed. We said it's better to understand what are the limits of the machine, what are the training of the team that work in the department, and what are it is our experience in doing this SRS SBRT program. So we look to that and try to find the dosimetric audit for SRS SBRT technique. Looking around, we found this opportunity to collaborate with RTsafe for SRS and SBRT technique. We found that RTsafe provides two type of audit using two type of phantoms. So we have first for SRS, it is called succeSRS, and for SBRT, it is called succeSBRT. These two programs, like I said, use two phantoms. succeSRS using a head phantom, it's RTsafe prime phantom, and for SBRT, it's using a thorax phantom, it's RTsafe SBRT phantom. Both phantoms are made by bones and soft tissue equivalent materials, and they are filled with water. And the nice part of this phantom, it is that they can be, let's say, they can have inserts with different detectors, starting from active detectors like ionization chamber, like diode or diamond detectors, to multiple OSL dosimetry kits or film dosimetry kits like GAF chromic EBT4, or gel dosimetry, that is 3D dosimetry. And also we have the chance to use these things that are calibrated to the secondary standard dosimetry laboratory. So it is something that have a very a nice and powerful background when you are using and you want to interpret the result that they are providing. This is let's say the facility. Let's see how it works, this facility. This is the workflow of the SRS SBRT program, and it is very nice because it's not interact with our clinical workflow. Is not strangling our program. Like I said, we have a lot of patient, and between the patient we can also do this audit. How it starts? First, we need to download the reference dataset. So RTsafe is providing the reference dataset for both phantoms with contouring. For example, for SRS program, we have 3 targets. One is like around 3.5 cc, and the other 2 targets are less than 0.5 cc. So we have a very custom, let's say, treatment with small target and the big target. Also for SBRT, we have a liver target, also organoid contoured. So we have already provide this in a standard way from RTsafe. Second step is to receive the phantom from RTsafe, and this phantom should be take care. Very important aspect is to read before receive this phantom, to read all the information, because we are using like OSDL and the film dosimetry, and very important gel dosimetry. We need to keep to some temperature in some conditions. So be careful when you want to use this, because the results can be affected on no proper manipulation of these detectors. Then we need to follow our protocol, SBRT SRS protocol, internal protocol. So this is like images from my clinic. First, we simulate the patient. This is the head phantom. Simulate the patient. Then we jump to the fusion with the data set from RTsafe. Then a radiation oncologist review the contours, and maybe he want to draw something else. Then we do the plan in the TPS, in our TPS, according with our internal, let's say, experience and protocol. And then after a plan evaluation, we will irradiate it like we irradiated a patient in a clinical life. After this, we need to load to the RTsafe database server all the information regarding the plan that we made it. This means CT, dose, plan, and structures, according with a short review of the plan, short conclusion of the plan. And after a very reasonable time, like 1 week, 2 week maximum, we can receive the result of this audit with a very comprehensive evaluation and a lot of explanation of the results. This is the workflow and how it's work. It's very easy. If you read before starting this all the documents, it will be very easy and don't impact your clinical activity. Now I arrive in the point where I want to share exactly what happened with our experience for the Halcyon machine, and I will start with the SBRT program. For SBRT program, we need to develop 3 plans, because we have 3 detectors, 2 films positioned in 2 directions, coronal and sagittal, and one detector. It was OSDL detector. The plan that we need to make it was a plan with 45 gray prescription in 5 fractions, so 9 gray per fraction. And the path, it was like this. We scanned the phantom with 1 insert, Then we go make the plan, evaluate the plan, treat the plan, extract the insert, put the next insert, again scan a plan, and then treat it, and so on. So we have three workflow that we need to follow for each type of detector. The plan in this case for Halcyon, it was a plan with 4 arcs to have much more, let's say, option for the TPS, and with this geometry of the gantry and the collimator, and the results of the plan are looking like this. We try to achieve what RTsafe documents ask for this plan, calculating also the gradient index, PADIC, and let's conformity index. So this was our result, and it was for this machine, it was closer to what the RTsafe documents ask for this kind of audit. Then we received the results, and the results are looking like this. First of all, let's look for OSL dosimetry. So here, if we look here on this picture, picture A, represent the central slice of the CT image stack on the Phantom that incorporated the OSDL. And the picture B represents the corresponding slice of the TPS calculated dose distribution that it's exported from RTDose file. That's why we load in there the server that information. And this tiny red solid line displays the direction in which the OSDL active volume lie. And C, this C picture, represent 1D profile TPS versus OSDL dataset of the dosimeter location according with the direction depicted of this tiny red solid line. And D, it is the gamma index for passing criteria. In this case of SBRT is 5% with 1.5 millimeter, according with the publication from task group AAPM. And the result for us, it was passing 100% in this case. The evaluation, it was made it with 30% threshold. And also the total combined uncertainty, it was around 3%. So this is the way how it's displayed the results for OSL dosimetry. For field dosimetry, we will have this absolute dose profile measurement versus TPS calculated data set. And we can see here with this correlation between these two measurements on field and also on TPS. This is an 1D analyze, but also we can provide much more information on 2D comparison between TPS and measurement on field, dose distribution in absolute dose in gray. So for low dose cutoff of threshold 30% with the global gamma, 5% with the same with 1.5 millimeters, we have this passing result of 99% passing. And for the also we have the chance, so it's not stopped just here to the recommendation. RTsafe is providing also other combination, other analysis like the 2x2 global or 3x2 local analysis. So it's providing a lot of information that you can use in your own analysis, internal analysis. The end of this audit for succeSRS, it was that it was passing. So for this audit, we have a very good experience. Then let's talk about our experience for the SRS. If we are looking in the literature, in some publications, some presentation, SBRT, it is recommended to be done on Halcyon. SRS, the opinion are half-half. So let's see what are the challenges here and what were the challenges for us in this succeSRS program. Here, this time we have to do the same methodology like SBRT program, but this time we add an extra plan for gel dosimetry, and the difference it is that we have a 3 target. It is SRS, and usually for this kind of treatment you need to do a non-coplanar planning, but in this case, as Halcyon doesn't have this opportunity, so we are stuck on this. So we try to do our best with what are the capability of the machine. These are the plan results. Of course, the condition that are coming from the recommendation of RTsafe documentation, it is to have a better gradient in the gradient index for the plans for each target. We were like almost there. So yeah, with the capability of this machine, you can reach the stringent condition that are coming for a real SRS program. For organ at risk, yeah, we achieve all the constraint. So this is the plan evaluation, and then let's jump to the results, because here we need to discuss a little bit. To discuss a little bit, we start with OSL dosimetry, and here it is something that we were not happy what happened, because we observe here the results that what is inside of the target, of that big target where the OSDL are positioning, the results were not so happy for us. If we analyze the gamma index for 5% with 1 millimeter this time, this is the recommendation, we are passing like 76%. So it is very, very low. And here we can see that the TPS, it's or OSDL dosimetry, it's over the estimation of the TPS. And this is confirmed also by film dosimetry for that big target, the bigger target. And we can see here the same approach. Like also, we can see not too big difference on the small target on the film dosimetry. Of course, OSDL didn't give us any information about this target, because OSDL are positioned just in the region of the bigger target. And here we can observe that on the coronal part, things are very, let's say, quite okay here. Not so okay, but it is a discrepancy between these small targets, and this is the big target. And yeah, also we can see here in the film 2D film evaluation, gamma evaluation, that in between coronal and sagittal we have a difference, and it is the same detector, it is the same phantom, the same planning approach. So the question it is that why the audit outcome it was failed. So for this, we evaluate what's happening, and we concluding that OSL dosimetry wasn't passed. It wasn't okay with our target. Film dosimetry, we can accept it that it at the limit, and for gel, I will present later. It was passing the result. So what will be the reason? This was our question. And the reason, first of all, we know that CT scan resolution can be, we identify this, that is possible reason. Also, Hounsfield unicity calibration curve or TPS algorithm, calculation, plan treatment modulation, so experience of the planner to match modulation, machine calibration or other machine QA stuff, or treatment irradiation, treatment positioning. And for this, we made an analysis, and together with the RTsafe team, we tried to find what were the reason for that to fail. And in the end, one of the possible reasons that we identify, and it remain, let's say, capability of the machine and modulation in the TPS and this CT scan resolution. And here, if we are looking to all the 4 images that we acquire, we have differences from the protocol that is recommended by the RTsafe documentation. So we supposed to be with the CT scan resolution and also AAPM publication recommend the same approach to be for SRS less than 0.7 millimeter resolution in plane resolution, and for SBRT less than 1 millimeter. And here it is like 1.3, 1.5, 1.3, and for gel dosimetry it's 0.7. So it is interesting because these things make also us to have a bad results. And let's talk about the impact of this let's say resolution governed by the pixel size and field of view in SRS SBRT cases. It directly impacts the target delineation accuracy, we know this, and mitigate the partial volume effect and ensure precise step gradient dose calculation for millimeter size tumors. For sure, we know this. And if we talk about these four effects, we can say that the first effect, high in-plane resolution, that means to have smaller pixels, prevent this averaging. This allows the treatment planning system to clearly define the exact border between the tumor and the healthy tissue. It prevents also the artificial shrinking or expanding of the GTV, which is crucial when delivering ablative, highly destructive dose of radiation. The second one, high in-plane spatial resolution allow the radiation oncologist to clearly visualize the boundaries of tiny closer critical structure. If in plane resolution it's very poor, organ at risk may appear blurred. This forced the planning team to use larger, safer margin, increasing the risk of underdosing the tumor or causing severe toxicity to healthy tissue. I will skip the image fusion with MRI and I will go to dose calculation accuracy. High in-plane resolution provide a precise density map of the patient anatomy. Treatment planning system, we know that requires this granularity to accurately calculate the dose distribution. Even the small pixel error can result in significant deviation in the dose delivered to the target or periphery of the target. And these three effects are coming from this CT scan resolution not properly chosen. And then I let the third one I let in the end because this is important. Yeah, we know that to use an MRI for planning, it must be fused co-registered with the planning CT. So high resolution in plane CT allows for precise, mathematically rigid fusion. Poor spatial resolution on the CT can lead to geometric mismatches that can go to 1-2 millimeters, so it causing significant targeting errors during the treatment. But here it is important in this end-to-end audit that we acquire and make the plan on this CT resolution, and during the let's say process of evaluation for film or for the other detectors, the phantom and the detector were scanned on the laboratory on MRI with a proper density or proper resolution. That is what is recommended for this kind of procedure. So this is also one of the reasons, and for sure it was the main reason for this discrepancy. Having this, we try to find what's happening, and we found that during our process, the RTT enlarged artificially increased the FOV, and the radiation oncologist and physicists didn't check in plane resolution when they made the plan. So it is important to have a clear protocol for SRS SBRT before starting this procedure. Then, because we believe that this was the reason, we repeat after 1 month and 1.5 months, we repeat the audit, and we redo the plans, and this time we can respect and have it the proper resolution. The plans are most similar. We change also something in the capability of the machine. If in the first attempt we use custom collimator angles, so what help us to prevent that bridge effect and aperture shape control off. Here we use default collimator angle and aperture shape control lower. We observe that we increase the number of mnemonic with 10%, but in the end the plan looks the same. So we send it, the detectors irradiate it, and then we receive the results. And this time it was something happy for us because we had 100% passing on OSL dosimetry with a very good agreement, and also for film dosimetry we have like 97%, 98% on the 2D evaluation from TPS to film dosimetry. That is very, very interesting that this audit show us what are the cracks in our let's say workflow. For gel dosimetry, from the beginning we were what we supposed to be. So we are happy that also this spatial evaluation can help us to trust this capability of the Halcyon for the treatment. Of course, this challenge to do the plan in some strict condition show us also some limitation of the machine. Halcyon is not 100% SRS SBRT machine, had some limitation during his non-couch rotation. In the end, the result was the passing, the outcome, it was passing, and we were happy with this because we learned a lot of things from this process. In the end, the conclusion it is that SRS and SBRT become increasingly common. This is the reason that we need to start this program in our center. And in particular, if we are looking to the Halcyon machine, they are increasing very highly. There are a lot of Halcyon machines. So this combination need of SRS, SBRT, and a lot of Halcyon need to be tested. The suite of measurement tools enabled by RTsafe Prime and SBRT Phantoms provide an array of tests to ensure the ongoing accuracy of the SRS SBRT program. And the result of this end-to-end test validate in our case the workflow and give us, like I said, the confidence to use Varian Halcyon for SRS SBRT treatments. Also show us the limitations, show us where to stop and what to not do on Halcyon for this kind of technique, and send in other centers that have capability. In particular, also this end-to-end test help us to cover some conditions that are in the legislation at the national level. Conducting some of the quicker tasks like OSL or film measurement after a 3D test like gel dosimetry, we can establish a baseline which can compare with regular periodical measurement to ensure the constancy of the system performance. And the guidance document emphasizes the need for regular end-to-end testing, like we saw in the recommendation from AAPM publication, RSS Medical Physics Practice Guideline 9.A. And being at the beginning of the journey with the team information, the use of end-to-end test audit program, it is mandatory in my opinion, in our opinion. Even legal requirement doesn't not impose it. And the final conclusion is the success of a SRS SBRT program is depending fundamentally of the optimal integration of the technology, of the human resources and training, and also the procedural components. We can see here that we test the technological, the capability of the machine, human, the training of the personnel, and also the procedural components, what we can improve for protocols for SRS SBRT program. And the full validation, it is, in my opinion, just an external end-to-end audit, independent, and also this opportunity of benchmarking to see where you are in this world with your machine, human resource, and procedural components. This is it, the final conclusion, and this last image that says thank you for your attention. It says that from every storm it starts a rainbow, and in this case there are also 2 rainbows. So once again, thank you for your attention, and I hope my experience will help you to improve your work in your clinic. And I am delighted to answer to your question. Thank you very much.
Great. Thank you so much for the great presentation, Florian. So in a moment, we're going to start answering some of your questions that you've been sending in whilst Florian's been presenting. But first of all, we have a question for you, the audience. So if you could take a moment and answer the following poll question. And the question is, which part of the radiotherapy chain for implementing SRS SBRT concerns you most? And the answers we have available are imaging, TPS calculations, patient positioning, and treatment delivery. We'll leave the poll question open for a few moments. If you can just send in your answers. And we'll keep that open for a few seconds. So first of all, the question is, which part of the radiotherapy chain for implementing SRS SBRT concerns you most? Imaging, TPS calculations, patient positioning, or treatment delivery? So we'll leave that open for about 10 more seconds. If you can just cast your votes. All right, thank you so much. Thank you for sending in your answers there. Okay, Florian, we can start going through the questions that have been submitted today. So our first question is, why should our centre perform an independent end-to-end audit if we already have a comprehensive QA program?
Thank you for this question, and this is a very, very, very nice question, because this is the question that I put it myself when we try to find this program. It is very important because runtime machine QA and patient-specific QA are essential. We know this, but they typically access individual components of the treatment chain. Like we said, all the treatment chain are verified independently. An end-to-end test audit evaluate the entire clinical workflow from the imaging part to the planning and positioning, and also the dose delivery. This approach provides additional confidence that the intended treatment is accurately delivered to the patient. So this is a very important, let's say, test, this kind of end-to-end approach. Imagine that I didn't mention this before I irradiate first attempt. I also made the QA of the plan, and I irradiate it on my patient-specific QA device, and the passing rate was very nice, very good. And then the results for end-to-end audit wasn't so happy. So yeah, I think this is the most powerful part of this end-to-end audit, this type of end-to-end audit. Thank you.
All right, thanks, Florian. Next question, what are the main benefits of working with RTsafe for SRS SBRT validation?
After this interaction, I can say that RTsafe is providing an independent assessment of the complete SRS SBRT workflow using this advanced anthropomorphic phantoms and high accuracy dosimetry. Beyond these measurements, these results that they provide, centers receive also the expert analysis and the support to identify potential areas for improvement, thereby also enhancing treatment quality, safety, and confidence in clinical implementation. And in my case, I can say that this was on top, because after failing, we have the chance to talk with the RTsafe team and to find where it was the problem, and they understand and they help us to solve the problem, to understand where is the problem.
All right, thank you, Florian. Next question, at what stage should a center consider performing an end-to-end audit?
Yeah, also this is a very good question, because it's related with my title. In my opinion, the ideal time is before launching a new SRS SBRT program, implementing a new treatment technique. It can be switching from, let's say, from even in the conventional radiotherapy, if you switch from 3D to IMRT, it is better to do also an end-to-end audit, even if it's not for SRS SBRT, but it is very important to do it. Also, you can find also a reason when you have a major workflow changes. You switch from one machine to other machine, or to another TPS to another TPS. However, establishing programs also benefit from periodic audits as part of the continuous quality assurance program, like we saw in the APM publication. Annually, if it can be done, it is perfect. It is much more perfect. But let's say, to concentrate on the main part of the question, I think it is a beginning of the journey. This is my personal answer, the beginning of the journey.
Okay, thank you. How disruptive is the audit process to our clinical workflow?
I said during the presentation, it wasn't disruptive. So the audit is designed to integrate smoothly into our routine clinical operation, and the center can perform the planning, imaging, quality assurance, and treatment delivery using our own standard clinical procedure. So it's not forcing us to do something that we don't have it. And the process requires minimal interruption of the patient treatment, while providing valuable information about the program's overall performance. So it is very, very friendly, to say like this. It is a very friendly process.
Great, thank you. How can an end-to-end audit help our hospital improve patient safety?
For sure, end-to-end audit can help my hospital. It helped my hospital to improve the patient safety. Like we saw, we have a fail first, and we improve our procedure. So SRS SBRT deliver high doses. We know this, with submillimeter precision. So this independent end-to-end audit verify the entire treatment workflow, and reducing that uncertainty that I presented, and also increasing the confidence in the treatment accuracy and patient safety. Of course, it is very important for the patient. Maybe we can imagine to have in an ideal world, to have an end-to-end audit dedicated to a specific patient. So each patient to have like an end-to-end audit after all the chain for that patient, to have also a phantom that simulate the patient and evaluate what will be the dose for that patient, the real dose. Thank you.
Thank you. I think we've got time for maybe one or two more questions. So what makes RTsafe different from other QA or audit solutions available on the market?
For sure, it is a difference between this approach of this end-to-end audit and the QA, the patient-specific QA solution that we have. It, like I explained, end-to-end audit give me some results, and I could connect with some missing part in my chain, in my workflow, my procedure. And on the other hand, the patient-specific QA device didn't find any issue with my plan. So RTsafe, it is a solution combines advanced phantom technology, high resolution dosimetry, extensive experience in stereotactic radiotherapy, and also personalized scientific support. Rather than focus only on the equipment performance, RTsafe evaluates the complete clinical process and works closely with the centers to ensure successful implementation and continuous improvement of their SRS SBRT program. So it is a difference in the, I can say it is a huge difference because we have the chance to measure on what we treat somehow like this. In the patient-specific QA, we have just a plan on the patient and it's evaluate on the other device. Thank you.
Thank you, Florian. And then I think we've got time for one more. You have done both the basic for SBRT and advanced for cranial SRS audits, the latter including 3D gel. What additional information did you obtain from 3D dosimetry and how useful is it?
From 3D dosimetry gel, so I didn't do for SBRT 3D dosimetry gel, also because it wasn't in the recommendation, and I let's say information that I get it from the 3D dosimetry gel. It was this patient positioning. So regarding the how the dose was delivered to the patient. So the information were regarding this let's say technical capability of the machine to make let's say the alignment of the CP planning with the CBCT, and to have a good let's say concordance between ISO centers of the treatment. And yeah, this that values that we will see there, we can ask they are good or not, and it depends of your protocol, it depends on your machine, and that experience with 1.2 millimeter, I think, on one axis, and less than 0.8 for the other axis, 0.7. I think it is a good let's say a good result for our machine in this case, where we don't have a 6D couch yet. We don't have yet a 6D couch. At that moment, we didn't look to update the machine with the 6D couch. That is possible now. So yeah, this is what helped me to know the positioning of the patient, the accuracy of the patient positioning according with what we plan.
All right, thank you so much. And thank you for answering those questions today. I'm afraid that is all the time we have for today's webinar, but if your question hasn't been answered, you will receive a reply by email. You will also receive a follow-up email within 24 to 48 hours with a link to view a recording of today's webinar. On behalf of RTsafe and Florian, thank you for joining us today, and please do enjoy the rest of your day. Thank you.
Thank you. Have a nice day, everybody. Thank you.